Okay, so this is lead code number 416, that is partition equal subset sum there. So what is given in the question there? First of all, we are given the array of integers. Our task is we have to determine whether we can partition the array into subsets such that their sum is equal to their sums are equal. So like let's say give for this test case 1 5 11 comma 5. So if we have to can we partition it? Yeah, so we can partition it like 1 comma 5 comma 5. So that is our array number 1 and 11 is our array number 2. So their sum are is equal to 11 and 11. So yes, we are able to partition it, but for it we can check where any of the cases we are not able to partition it. So we simply return true or false in the cases we are able or not there. Okay, so like what's the intuition here? So since we can say one thing there, like if our array can be divided into two equal subsets here, so what it means, let's say our total sum of our array is equal to sum here. So we can say one thing there, like if we want to partition it in two subset there, so what it means, each subset must have a sum is equal to sum by 2 if our total sum is equal to sum there. So if we split in our two subset here, so what it means, each subset must have the sum is equal to sum by 2. So simply our problem becomes, can we are able to find a subset whose sum is equal to sum by 2. So this is same as like our previous problem where we have to find whether we are able to find any of the subset whose sum is equal to target, and like since there in the question the target is a variable, it is given in the question, but here it is nothing but the target is simply become our total sum by 2. So that is a similar question. So I think you should also see our the last video that in which we have to do the question in which we have to return true or false in the case if we are able to find any of the subset whose sum is equal to target that is given in the question there. Okay, so now coming to this question also, so like like we can simplify this question here. It is nothing but, can we find a subset whose sum is equal to sum by 2? Okay, so if such a subset exists, so it is guaranteed, it is the remaining elements automatically form the other subset with the same sum. Okay, so therefore this problem simplified directly become the subset sum equal to k. So okay, so like we can say one thing there, first of all we can eliminate some of the edge cases there. Like we can say one thing, if our total sum is equal to odd, so we cannot divide it in our two equal integer, so we simply return our answer is equal to false there. So we handle those cases already in our main function, like for not we are not we are not doing our code for that cases also. Like there's we initialize our total sum is equal to 0, we traverse all of the array and simply store in our total sum. Now check if it is odd. So since it is odd, so it is not possible to partition in our partition in two subset with equal sum array, so we simply return false in that case. Okay, and after it, if sum is equal to even, so our target becomes sum by 2. And now this question is simply become, that's our last question, so I'm not explain again and again for this question or again. So you should go for my last video in which I have to do the question that is subset sum equal to k. So I think so this question is nothing but the simply extension of that question. Okay, so this is one specific when we have to adjust one specific value for our target. So you can see one code again there also, like we simply check for this edge case, for odd case there, return this function there, their definition it is same again same, the target is 0, we simply return. If we have to reach to our array, we simply return our like return false condition there. And there's the two cases where the for the take or for the skip, and since we are not guaranteed if we are able or not, so that's why we initialize with our bool function with false there, and check if it is less than is equal to target, means we are able. So we simply take that part, so take becomes sol of I plus 1 comma target minus target reduces there. And if we have to skip, does not need to reduce the target, I simply call index plus 1 for both of the cases there. And like simply this again if this is not acceptable, it since its time complexity is exponential, so we should go for the memoirs. It is remain again the same. There's no need, there's simply we use one dp vector there with a dp of n comma n cross target plus one size there. So it's again same thing there. So time complexity is become n into target and space complexity is this. Okay, so this is a question.